analyze our plant profitability. As Fernando has said, we will do a break of 3 minutes at the mid-time of this webinar session. And well, at the end of this session, we will try to ask some of the questions, but please consider that maybe some questions for this session require harder analysis and will be answered by email. So anyway, we will try to answer you most of the questions that you have. Please inform me through the chat if the sound is not good, but well, I guess there is no problem with the sound tests. So, Fernando, did you want to say anything? No? Okay. So, well, we will divide this webinar into 3 chapters. First, we will review how to calculate the expenses during the plant operation. Then we will do a deeper analysis on how to choose our insurance. And finally, we will end this webinar studying some examples of project cash flows and the international rate of return. So let's start with the first chapter about the expenses of the plant operation. As we have already studied during the 4th webinar session, the main expenses that we are going to find during our plant operation will be the plant operators and the maintenance staff, the stock of the spare parts, and the stock of all the consumable elements such as the oil and the paint, the surveillance and the monitoring system, the insurance that we have to contract, the land that we have to rent, other supplies, and the taxes. For those people who couldn't attend to the last webinar, and also in order to review for those who could listen to it, we will do a quick overview on each of the issues in this list. About the plant staff, we have to know that the cost will depend mainly on the amount of people we want to employ and the skills of those people. Normally, it is very important to have at least one well-trained supervisor in both a functional and a documentary level. As we said, in the functional level, he will need to have electrical and mechanical skills to handle with the plant reparation by himself. If we have a very good supervisor, he can even handle the reparation of several different plants from our company. Mechanical skills are really important if we are using sun trackers in our PV facility. In the documentary level, he has to have the ability to create records and documents in order to log and report all the incidents that happen in the plant, so that we can analyze them and use them for the corrective maintenance and the preventive maintenance. About the spare parts stock, it is essential to have an updated list of all the spare parts available in the plant, assuring there is enough quantity of each element. If an incident happens, we will have to react the faster than we can, and not having a critical piece could mean the stop of the whole plant, or a part of it, but obviously it might generate serious production losses until we can repair this device. The same happens with the stock of consumables, but in a lower level. We have to guarantee the availability of all the critical consumables, such as oil if we are using sun trackers in our solar plant. Maybe this will not produce the plant stop, but not having enough oil to lubricate all the motors may cause a serial inconvenience to us and even economic losses in the way to manage these consumables. About the monitoring and surveillance systems, we have already talked several times, but it is important to know that the inconvenience caused because of theft can mean a high cost for us, not only because of the stolen elements that we have to replace, but also for the production losses and the labor works. We will talk about later, but the insurance normally doesn't cover the production losses, and we have to expressly define the coverage of this kind of losses. Anyway, talking about the surveillance system, we recommend a combination of a remote surveillance system, for example, based in video cameras, and the usage of physical surveillance contracting our own staff or outsourcing it from a specialized company. The same happens with the monitoring system. It has a great influence in our plant profitability. A good monitoring system can be critical for the plant maintenance, allowing us to detect any incidents just when it happens, so that we can repair it as fast as possible before it causes any serious production losses. For example, in our solar plants, we have monitoring systems that control the energy that is being produced in the meters, and that makes a comparison between all the different sun trackers in our solar plant. So, if we detect in real time that one of them is producing less than it should be producing, we can repair with the personnel that we have always in our solar plants in order to repair them as soon as possible. About the insurance, as I have already said, we will talk lately. But for the land renting contract, it is essential that the contract guarantees us the operation of the plant during its whole lifetime. We will talk about it later, but although the plant studies are usually made for 25 years, because it's also the time when the panel is guaranteed, the plant will probably last more than 25 years. Obviously, if we are talking about a roof, we have to check that the building will last 25 years, and that no other building will be set close to ours, because we have to pay attention that any building that will be constructed in the future may cause new shadows in our installation. We also have to know that the urban terrain is much more expensive than the terrain in rural areas when selecting the land that we want to contract. About the supplies, in fact, they are not very important to the cost if we take as a reference the whole budget for our solar plant. And the taxes, we have to know that sometimes there are compensations that are expressly taken into account for renewable energies. So it is important to check with our government if we can take one of those compensations. So during the next chapter we will focus in the insurance analysis. There are two key points where we have to focus before selecting the best insurance for our PV facility. As we see in this slide, first we have to do the identification of all the possible risks that can happen in our solar plant, and the study of all of the assets, such as the devices and equipment in the PV facility, and all the interests, like any production losses that we want to protect. Second, we have to study the expected coverage of our insurance. Normally, we should consider covering the plant execution, the plant operation, and the civil responsibility with the same insurance or with separate insurances. We will talk about it during this webinar, but it is important to know this point, that we have to cover separately the execution and the plant operation. As we will see later, the plant execution will have always all insurance risks. Well, it is recommended, but the plant operation we can choose from a multi-risk insurance or an all-risk insurance. Anyway, we will talk about it later. In this slide, you can find a list that can help you with the identifications of the risk in your own PV facility. We have classified them into two groups. The first group includes those risks that could be covered by the insurance. It is very important considering all of them before choosing definitely our insurance program. It can be quite disappointing finding that an incident was not covered by our insurance company just when it has happened. The main insurable risks will be the risk from the nature, like hailstorms, flooding, wind effects that can damage our sun trackers, maybe in some countries earthquakes. Then all the risks that may be covered by the surveillance system, like the theft, the vandalism, the terrorism, or the sabotage. Here, it is important to insist that our surveillance system must be a good one in order to cover us from this, because sometimes even the insurance can ask us for information about the surveillance system that we have installed. The execution defects means any incidents that can happen during the project execution, such as delays because we have already received defectuous material and we have to replace it, or the safety of our workers during the project execution. Another insurable risk could be the losses due to facility stoppage, but we have already said, and we are going to insist about it, that we have to expressly demand the coverage of this kind of losses, because most of the insurance don't cover them. Another risk would be the breakdown of equipment during the plant execution, but also during the plant operation. A typical example could happen if we don't have a well-implemented corrective maintenance program. For example, imagine that we forget lubricating the motors of a PV plant using sun trackers. This can cause serious damages to the elements in that sun tracker, but this can also produce production losses and losses for the laborers. So we have to have spare parts in the solar plant in order to avoid this kind of incidents, and also contract an insurance that protects us for production losses. Finally, the last insurable risk would be the responsibilities for third persons damages. By the other side, we have some examples here of non-insurable risks. They would be, for example, the political or social or financial risks that, for example, can happen if the tariffs change due to a political decision, or if the loan interest vary drastically and we have not considered that in our profitability analysis. Another non-insurable risk would be the technological or professional risk. For example, if we have chosen a non-mature technology like a high concentration technology and the performance that we are getting from our solar plant is lower than the one that we had expected. Finally, other kind of risk would be the strategic risks. Once studied the main risk to cover, we will analyze how to choose the best insurance program for our plant. Our main goal must be to protect our interests. We have to consider both the interests of the owner company and the financing company. Sometimes it is not the same company, so we have to consider both. But anyway, in both cases, the main interest will be nearly the same. To protect their patrimony, this means all the assets that the project includes, and to protect the project profitability. So, our insurance must cover our assets, like the infrastructure, the devices, and equipment, our income, insisting in the system losses, and also the responsibilities. It is important to know that the insurance must cover two defined periods, as we have already said during the beginning of this webinar: the plant execution and the plant operation. We will study both of them during the rest of this chapter. So, starting with the insurance program during the execution, we will say that it is recommended to get an all-risk insurance. This kind of insurance covers all the possible risks during the project execution. The main elements to cover with the insurance are the foundations, all the equipment in the solar plant, talking particularly about the modules and the inverters, all the constructions and fences, all the civil and electrical works, and the equipment of protection that protect our devices in the plant. We have to cover them from all the possible risks, such as the transportation from the manufacturers to our solar PV facility, because they are already outside from the manufacturer and we can have problems with them if we receive, they deliver defectuous material which is broken. Also during the load and unload of material from the truck, during the assembly, and we have to consider here the skills of our workers, during the pre-installation, the stockage, and the installation, and also very important during the tests and commissioning. Here we have said the maintenance, but obviously the maintenance will be during the plant operation. Anyway, it is important to know that an all-risk insurance will cover all direct, sudden, and unforeseen damages that are not explicitly excluded from the contract signed with the insurance company. Here we have a table that includes all the covertures from an all-risk insurance during the plant execution. We have to cover ourselves for 4 types of risks: the ordinary risks, the natural risks, the staging risks, and we have to also consider some optional risks. Ordinary risk will be, for example, fire or explosion caused by our own staff or by the malfunctions of our devices that we have selected. Also, it could happen that some of the elements could be stolen during the plant execution. So here we won't have the surveillance system because the plant is not being operated yet, and we have to consider the theft, the possible thefts of the materials during the execution. So a good practice could be stocking the materials in an area close with a fence, and the critical materials such as the inverters could be stocked in a room with a lock. Natural risks, which are not as important now as they are during the plant operation, could be the wind, the snow, the rain, the frost and the frost effects that can cause our panels to break. The floods because of rain or because of our plant can be close to a river, and earthquakes, but we will insist about them during the plant operation. Staging risks, that means that those risks which are just from the plant execution would be of two types. Technical risks, because we have designed, for example, because we have designed badly our plant, or because we are doing bad managing of the materials that we receive, because during the assembly our workers can have any problems such as short circuit or overvoltage, or because when we are doing the test for the commissioning of our plant, some incidents can happen because of bad connections of the equipment. Also, human errors can happen due to inexperience or to negligence. Finally, we have to choose the optional risk that we want to cover. For example, we can get an insurance that covers the consequences of a design mistake, but this is very difficult. And no insurance will cover a strike, a riot on a civil accommodation. Anyway, it is important to consider that all the risks that are not excluded from the policy will be included in an all-risk insurance. The requirements for contracting a good all-risk policy for the execution of the plant will be analyzing well all the situations of risk, so checking all the possible issues and incidents that may happen during the execution. We can use the list that we have already seen in this webinar. Also installing protection and vigilance measures. Here we have to insist that the surveillance system will normally not be working at the moment, so we have to avoid with different mechanisms the materials from being stolen. And also controlling that all the subcontractors and workers within the companies that are working in our project must be working in a safe way or have their own insurances. Anyway, it is important to know that all the persons and companies who are involved in the plant execution must have an insurance. So, the promoter, the operating company, the financial company, and those subcontractors or workers, if they are not included in our insurance, they must have their own insurance. Talking now about the insurance program during the plant operation, the first point to consider is that now it is not like during the plant execution. Now we can choose between an all-risk insurance or a multi-risk insurance, and selecting one or the other can mean good savings for our solar plant. So, now the elements to ensure are nearly the same than during the plant execution. The foundation, the models and equipments, the fences and constructions, the civil and electrical works, and the protections. We all know the difference of both types of insurance, an all-risk insurance and a multi-risk insurance in general, but we will study them in the following slides when we are considering them for a PV solar facility. Anyway, talking about the contract that we have to sign with the company, a multi-risk coverage insurance details in the contract the reasons that are considered recoverable disasters from the company and doesn't include, or doesn't reflect as the all-risk coverage only the exclusions of those things and those issues which will not be recoverable from the insurance company. Here we can have a table like the one that we had during the plant execution for a multi-risk insurance and the coverage that it must or that it should have. We have some basic guarantees that have to be covered, like the fire, explosion, or a strike. Then, in a multi-risk insurance, we can extend the guarantees, and we recommend to do it for the natural phenomenon such as rain or wind. Especially, we have to include the wind insurance in case of using sun trackers. Another optional guarantees in multi-risk insurance could be the guarantees for thefts and for the all the elements being stolen, the guarantees for electrical damages, the guarantees for possible breakdowns in the equipment. Here we will recommend you to include the breakdowns of the inverters, and it is really weird that it includes the loss of benefits because of production losses when we are talking about multi-risk insurance. Anyway, it will be really important to include civil responsibility if we are getting a multi-risk insurance. For all-risk insurance, normally they include everything that we have seen in the last slide, and they exclude what they are saying that they are excluding in their contract, which would usually be bad intentions from the contractor, which is something that it's quite weird to happen, a design mistake. So it is very important to follow all the checklist that we have reviewed during the last webinars in order to guarantee that we have not committed any design mistake, and the degradation for the elements in your solar plant. Anyway, here we have to say that the main element to suffer degradation would be the solar modules, and as we have also said, this degradation is usually guaranteed by the manufacturer of the modules. In order to remember you, I will say that normally the manufacturers of crystalline modules guarantee that during the first 25 years, a 20% degradation will be produced in the modules. Some of them also include another clause to guarantee that during the first 10 years, the degradation won't be higher than a 10%. The only optional guarantee that we can find for a plant operation if we get an all-risk insurance will be guaranteeing the production losses and the labor's times. Here we will recommend including this kind of losses, but you have to consider the price of including them and the risk of this kind of losses to happen. Normally, a facility with sun tracker systems can be risky, more risky than a facility without using them. So particularly if you are selecting or if you have chosen a facility with sun trackers, consider one of these optional guarantees. Anyway, both talking about the multi-risk or the all-risk insurance, it is very important to cover the civil responsibility during the exploitation for the employers of our solar plant or for any damages causes to the energy receptor from the company. Now, as we did with the plant execution, before contracting, we have to check the requirements of the contract that we want to sign. So we have to do also an analysis of all the possible risks that may happen. We have to consider the protection and vigilance measures that we have taken into account, but here we will have normally operating our surveillance system, and we have to consider the control of operation and maintenance contracts when selecting the insurance. Because if we have got, for example, a contract with an outsourcing company that guarantees us the maintenance of the equipment, then we won't need an insurance, such a good insurance as if we are doing the maintenance in our own. Anyway, we have to consider, for example, the availability of solar modules in the market. Now, the companies that should get the insurance would be the operating company and the financial company. Obviously, if we have outsourced the maintenance, we have to check that the outsourcing company also has an insurance. So, Fernando, if you want, we can do a 3 to 5 minutes break at this moment.
Okay, thank you very much, Javier, for your presentation. So we will do a short break to speak the audience. So this is the fifth session of this photovoltaic installations training. We have seen a chapter on design, then on plant operation, plant maintenance, and today we are checking the economic figures, insurances, and expenses of the plant operation. So there is one chapter which is dedicated to isolated installations of off-grid. It will be next week. In the meanwhile, there are other webinars scheduled, so particularly October, one dedicated to concentrated solar power. So we will see market figures, we will see other features like desalination using solar energy, and as well we will see the solar resource assessment. So check in Leonardo Energy website second CSP training. Very well, so I let you interact online. I see that the chat is quite active today, so do not hesitate to further keep in touch by joining the LinkedIn group, which is presented in the link on the lower right corner, and you can further interact with other participants. We will resume the presentation in about 1-2 minutes. Thank you very much. You can remain connected. Okay, very well. So now we can resume the presentation. So Javier, the floor is yours. Thank you.
Thank you, Fernando. So we will resume the presentation in the last chapter, beginning with the last chapter, where we're going to analyze the project cash flow and the internal rate of return. Please consider here that in sometimes we have written IIR, and well, it is wrong. Obviously, we wanted to write IRR, which is the acronym for internal rate of return. For this profitability analysis, we have considered the inputs that you can find in this slide. So we have considered that the installed peak power will be at 10% more than the nominal power that we have considered for the project. This is a typical thing to consider. We will consider a module degradation of 1% per year, which is also quite a good consideration if we take into account that the panels manufacturer guarantee a 10% during the first 10 years and then a 20% during the rest 15 years. So, well, it could be a good consideration. We are also considering an increase of the price of the electricity of 2.5% per year, and we have chosen a loan of 12 years with a grace period of 1 year, and well, we have considered an interest rate of 5%, though the most of the financing facilities have a variable type which is indexed to the Euribor. And finally, we have considered an equity of 20%, so we are considering a loan of an 80%. Here in this table, you can find some considerations which normally depend on the type of installation. So you have in the column in the middle the investment that we have considered for each type of installation. Obviously, you have to know that this is a typical consideration, but this investment will depend on the manufacturers that we are choosing, and also it might depend on the size of our solar plant. For example, for a fixed-to-ground crystalline module facility, we have chosen an investment of 2.9 euros, and you can see there that if we are using thin film, the investment will be a little bit cheaper, and if we are using sun trackers, it will obviously be much more expensive. Normally, from about a 30 to a 35% more expensive. Also, you can find that the facilities in roofs are a little bit more expensive, like 0.1 euros more expensive per watt peak if the facility is installed in the roof. Also, well, we have selected or we have considered an operation and maintenance cost that it's the same for all these types of installations. We have considered a fixed cost of 200 euros, and because it is the minimum cost, and we have considered a 2% of the incomes of the energy that we are producing as a cost of the maintenance. So this has been done in order to take into account the different sizes for the different projects. Anyway, we have not considered the insurance and physical surveillance in the operations and maintenance cost, as it is very variable. Also, in this 2%, we can it has been also considered, because if we are using sun trackers, then the energy that we are producing will be higher, but also the maintenance cost will be higher, because those sun trackers need specific maintenance. Well, there you have a consideration that in some countries the price might also be cheaper because of the administrative simplifications, or because of the government taxes. For example, in Germany, the price will be 0.1 euros cheaper than a plant in Spain within the same continent, Europe. Here, well, this we have selected a map in order to explain you a little bit the considerations in our profitability analysis. We have selected different types of installations in these two countries, which are one of the world leaders in solar energy. We have considered facilities in Germany and in Spain. In Germany, we can have an estimated production of about 950 kilowatt hours per kilowatt peak per year, and we have a subvention with a feed-in tariff of 0.28 euros per kilowatt hour for ground facilities, and a variable subvention for roof facilities that can go from 0.29 to 0.37 euros per kilowatt hour, depending on the size of the facility. In Spain, we have more or less the same type of subvention with feed-in tariffs also. We can get 0.26 euros per kilowatt hour for a ground facility, and for roof facilities it is also variable from 0.29 to 0.33 euros per kilowatt hour. Obviously, the subvention is lower in Spain than in Germany, because you can see there that the estimated production in Spain is higher than in Germany. In Spain, we can expect producing about 1,350 kilowatt hours per kilowatt peak as an average. For other parts in the world, obviously, we have to check the estimated production and how much is the price that the government or the consumer are paying for the energy. We insist that in these countries that we have selected, the energy produced by renewable energies, especially from photovoltaic energy, it is subventioned. So here you have the resume on the 5 study cases that we have included in this webinar session. You can see that in order to make easier the analysis, we have selected a power of 100 kilowatts or 1 megawatt, depending on the type of technology. You can also find the different subventions, estimated production, and obviously investment price for the different types of plants that we have included in the webinar. Anyway, during the rest of the webinar, we will study each case separately. Obviously, because we haven't said it yet, you can check that the estimated production for a sun tracker plant in Spain is like a 35% or a 38% higher than the estimated production that we will have for a ground plant. Here, I don't know if you can see it properly in this slide, but you have an analysis of the profitability of the first study case. We have done this kind of tables for the 5 study cases. Anyway, I think, well, Fernando will confirm it later, but I think that you can download the presentation we are doing. So there you can have clear data of all this resume. and you can probably have a better look at these tables. But well, I'm going to try to tell you a little bit about this. I'm going to try to explain you this study case. So we have considered 25 years, which is the typical lifetime that that companies in photovoltaic energy consider for their installations. Obviously, we have to know that the installations can last more than 25 years, so any income that will come from the 25th year will be just an income for us. We have considered a loan fee, a loan of 12 years, and as we said, for 1 megawatt in facility, we are considering an investment of 2.9 million. So the 20%, no, sorry, I think the investment, I didn't say it properly. Okay, well, it will be multiplying the power by the estimated price per watt peak, so it would be about 2.9 million euros. So here we can find the loan fee that we will have to pay during the first 12 years, that we have considered a flat loan fee, so the same for all the years. And we have considered in the second column for the outputs a maintenance cost of of a percentage, as we said, of the incomes, that as the incomes are higher each year because of the RPA, then the maintenance cost will also be higher. So as a result, we have the cash flow, which would be the subtraction from the incomes less the loan fee and less the maintenance cost. We can see that during the first 12 years, as we have to pay the loan fee, we are getting lower cash flow than from the rest of the years. Anyway, if we check these tables in the accrued income, we can see that we have a payback of our investment on the 6th year. We get the amortization of the investment. So another consideration would be that if we get higher amortizations of the loan, then we can even get to have a negative cash flow during the first years. But obviously, if we get a shorter amortization, normally the benefits in the accrued income at the end of the project will be higher. So that is a consideration depending on the equity that we want to invest and the equity that we can get from our financial company. Here you can have a resume of this study case. So you can see that we have done an investment of 3,190,000 euros, 3,190,000 euros, so a little bit higher than the one I was considering. We can get an average income per year of 385,000 euros. This is for the first year, and then the rest of the years, obviously, because of the retail price index, this income will be higher, and also because of the price of the electricity that in some countries may vary. Here we are considering a feed-in tariff flat of 0.26 euros per kilowatt hour. We have used for this analysis a loan, as we defined in the slide of the inputs, of the 80% of the investment, so a loan of 2,552,000 euros. And finally, we can expect for this study case an internal return rate of 23.07%. This is, if you note about financial economy, this is a very, very high internal rate of return. So it would be a very attractive project for any financial company. Here you have another study case for a thin film module. You can check that as the investment is a little bit lower, we have lower loan fees. And well, I think we are going only to overview the different resumes for all the installations. For example, as the price is lower in this case, and the estimated production has been nearly the same, we can get a higher internal rate of return for this investment than the one we got for the crystalline modules. Please consider that this is just a smart analysis, and a proper analysis must be done before getting into a project, because normally the internal rate of return of the crystalline projects and the thin film projects can vary depending on the temperature and on the price of the land that we want to rent. Here we have the resume for an installation of 100 kilowatts on a roof in Germany. You can see that the internal rate of return, well, I'm always talking about the internal rate of return because it's the tool that is the most used all over the world to check the profitability of the investment for solar investment. Normally, financial companies, they will ask you about the internal rate of return. Here we can find an internal rate of return of 22.35, whereas if we are considering a roof installation in Spain for the same size, we can get a higher internal rate of return of about 26.4%. Obviously, as we have more energy in Spain and the feed-in tariff is more or less the same, we can get higher internal rate of returns in Spain than the ones that we get in Germany. Anyway, we have to check the feed-in tariffs for the year that when we are executing our facility, because it can vary a lot from a year to another. Final project will be a sun tracking system project in Spain, and here you can check that as the price is higher, the internal rate of return may be lower. It is about at 22.7%, while in a ground installation without sun trackers with the same kind of modules, it would be at 23.07. Anyway, in the next slide we have a resume, and here we can have an overview on the different types of installations and their internal rate of return. Sorry for the TIR acronym that is set in the last row. We meant internal rate of return. That is the acronym in Spanish. Well, as I was saying, the internal rate of return might be nearly the same in a sun tracking facility than in a ground facility, but we have to consider here that the risks for a sun tracking facility are higher than the risks for a ground facility, and this is one of the main reasons why sun tracking systems are not being used nowadays. So with this resume, we finish with this webinar session number 5. And now I think that if we have some time, we will ask some of your questions. But as I have already said, please consider that some questions may require deeper analysis, and maybe we need some time to answer some of them. So Fernando, I give you the word. I thank everybody for attending the meeting, and we will continue with the question session.
Okay, very well. Thank you very much, Javier, for your presentation. So we launch now some minutes of questions and answers. So I let you, Javier, to select the most representative questions and provide an answer. Thank you very much. In the meanwhile, remain connected. Javier is reading your questions, selecting, and then providing an answer. Thank you very much.
Okay, so Fernando, we have already selected the first question to answer, because I think it is quite an interesting question. There is a person that is asking, how can you consider a peak power 10% higher than the nominal power? Well, we have considered this in the inputs for our profitability analysis, because from the panels, well, normally the nominal power that we are talking about is the power of the inverter. So already from the panels to the inverter, there are some system losses due to the temperature and due to, well, to different considerations such as the cables or even the tolerance of the panels. So a good practice is installing a 10% more of panels than the peak power than the nominal power we are considering for the inverter. So for example, if we have a facility of 100 kilowatts nominal power, this will mean power in the inverter of 100 kilowatts, but installing 110 kilowatts of power in the panels. I think that with that, well, all the people can have it clear what we meant. There is a person that is asking what percentage of increase in electrical energy price did we take into account for the profitability analysis. Well, it is written in the inputs slide, but we have taken into account for Spain, well, for a typical case, sorry, in Spain or in Germany, an increase of the electrical energy price of 2.5%. This is because it's the typical increase to consider here in Spain, because of the last increases during the last years. We got the average, and we got this price increase. Normally, the price of the energy increase due to its own life, because it's variable in its own, but it also can grow because of the retail price index growing that varies each year. Okay, there is a person who is asking for a particular case in Spain, but that can be done anywhere in the world. He says that if in a roof the price is about 3 euros per kilowatt peak, then that means that this is the payment that we have to do before starting the PV installation, so in the in the year 0. But he's asking that then what does the loan mean? Which concepts are we paying with the loan? Where obviously, when we are considering this price per kilowatt peak, this is the price of the investment. But before doing the investment, we have to ask for a loan to any financial company, and then we will pay the facility with this loan. So that's why we were speaking about the amortization of the loan. This means that from the total budget of the facility, in the examples that we have done, we have considered that an 80% will be paid with a loan and a 20% will be paid by our own equity. So this means that during the first years of lifetime of our facility, we will have to be paying the loan, but the concepts that we are paying with that loan are obviously the facility that it's already producing. This is why we have talked about the amortization of the loan, and we have said that if you get the amortization of the loan in less years, you can even get a negative cash flow during the first years of lifetime of the project. So we have to do a balance between the loan duration and the cash flow that we want to get during the first years. Fernando, you tell me when I stop with this question and answer session. I think you said that we will be answering for 4 or 5 questions. So I have selected a new question, which is quite long, but very interesting. I think it comes from Indonesia. There is a person that says, from what I can see, investments in these plants are only feasible if the feed-in tariff is attractive. In Indonesia, you would have to operate as an IPP, and you are forced to sell the power to the national power company. They will pay maybe 0.08 US dollars per kilowatt hour. So he's asking, can this plant also be used to apply for carbon credits and thus get additional income? So the answer to this question, in fact, depends on each country. For example, here in Spain, we already do have the feed-in tariff that makes feasible plants of this type in Spain. But in some other countries, we have news. We haven't done any project of this kind yet, but probably you have to study with each government if you can get carbon credits for this kind of facility. But if the government has agreements between different governments, then you can get this kind of subventions for sure. Anyway, what you have to know is that some countries, like for example Spain or Germany, and this is why we have selected these countries for for these studies have selected doing feed-in tariffs, and this is why they have become leaders in these sectors, in this renewable energy sector. But the technology is increasing a lot and is improving, and there is a concept that I think that we have already mentioned during the first webinar, which is called grid parity, which means when the price of electricity that we are producing from a solar plant will be the same price as the price that the consumers are getting from their solar plants. This concept of grid parity with the consumer's price is used in a lot of countries to install a system which is called net metering. This means that an user can install into his house, over his house, a solar plant, a small solar plant, and then all the energy that he's producing from the solar panel, he will consume it in his house. So if this energy is cheaper than the energy that he has to buy from the grid, which is not this price that this user from Indonesia is saying us, but a higher price, then he can save that costs. The net metering concept includes a different consideration which allows us to use the grid as a battery, so that we don't have to consume the energy generated from the solar panels in the moment that it is being generated, but we can use that equivalent energy whenever we need it. So, well, you have to check in any country in the world that you want to do this kind of project, if they do have one of these subventional systems, such as the net metering or the feed-in tariff, or if each particular government can allow you to apply for carbon credits.
Yes, so just to complete your answer, we made in the past some webinars on the carbon market. So we used to work with Dauman consultants. I put into the chat the link to their company, so dauman.com. So you can always be in touch with these guys. They have developed several projects both in Latin America and also in Africa that applied for carbon credits. So they could inform you about how good is the carbon market today, what are the expectations for the near future, how feasible is to apply for carbon credits in your country, and finally whether it's a good investment, this photovoltaic installation as IPP in your country, or if you would better invest as let's say as a particular, as an individual for your own consumption, in which case your benchmark price is higher than the reference that you indicated there. Okay, very well. So Javier, if you want to proceed with one more question, and it will probably be the last. Thank you.
Okay, Fernando, thank you very much for that considerations about the carbon market. They are very interesting. Yes, we have found another question that can be interesting. It is a question that we have, I think, insisted a lot during this webinar session. So that's why I want to insist once more. There is a person that is asking, are thin film panels better to use in countries with high temperature? And well, the answer is that these thin film modules, the thin film module technology, has a better performance with temperature than crystalline modules. So the answer will probably be yes, if we can get cheap thin film modules in that country, because while we can consider a 4% system losses if we are using, well, we can consider a 4% losses if we are using crystalline modules for every 10 degrees over 25 degrees. If we are using thin film modules, we only have to consider a 2% of losses for every 10 degrees. So it will be better getting thin film models in countries with high temperature, yes.
Okay, thank you very much. So we have to close the session today. Thank you very much for your interest and your participation. Thank you very much, Javier, for your explanations again today. See you next week for the last session of this training. We will see some particular aspects of off-grid installations. So see you soon in the webinar program. Thank you very much.
Well, thank you.